Discovering exactly how the moon formed is key to finding out why it has two such distinct sides. And as a young astronomer, Bill and his colleagues thought the answer could lie in what they saw on the moon's surface.
We discovered this big impact basin on one side of the moon, which really seemed to solidify the idea that these crater-like features are not volcanic. These are formed by big impacts. So you have lots of interplanetary debris hitting the moon all the time.
These impacts gave Bill the idea that the history of the moon is tied to that of our own planet. He suggested that as the Earth was forming, another smaller planet might have formed in a similar orbit around the Sun. As the planets circled our star, their paths inevitably crossed, with catastrophic consequences. The resulting collision caused an enormous explosion, throwing up a vast cloud of gas and dust around our planet. This superheated debris then combined, forming a new molten body, one that slowly cooled to form our moon. In the early 1980s, a conference was proposed to see if scientists could agree on a story for the moon's origins.
It was decided, let's have that conference in Hawaii. Sure enough, everybody wanted to come to the conference all of a sudden. Everybody's wearing their Hawaiian flower leis.
Right. It's amazing how many people were wearing beards in those days.
Having worked out the details with his colleague Don Davis, it was time for Bill's theory to face some tough scrutiny.
And that meeting has been sometimes described as one of the most significant meetings in planetary science. We went through lots of different theories, and the giant impact theory was the one that got the A+.
The giant impact hypothesis still reigns supreme as the go-to theory of how our moon was formed.
It seems to fit so many criteria of what we know about the solar system that I think it's still a major part of planetary science.
Bill and Don's theory explains a lot about our unusual moon. The sheer amount of debris thrown up by such a vast collision would lead to its unusual size. But the theory offers no explanation why the radioactive elements found in the Apollo samples are more common on the near side today. And it doesn't explain the far side's much thicker crust, or even the surprising differences in appearance revealed by the Lunar 3 probe. Today, in the race to explain the mystery, 3 competing theories stand out. All 3 begin with the giant impact hypothesis. But it's what happened next to cause the moon's two-sided nature where they all disagree.